Class, in Chapter 9, you're going to explore a series of different approaches, different applications of linear programming. You're technically not going to learn anything new as we have in previous chapters, and actually as we are going to learn in Chapter 10 and 11. There's nothing really new here except in one problem. I'll tell you more about it later. This is all about different applications in different fields of business and actually even in engineering. So let's just jump to it. Let's do the first one, which is the media selection problem, and you can follow along with the slides. I'm gonna just show you the Excel spreadsheet where I go through the entire problem. So the media selection problem, it's all about a company called SMM, who's going to, this company is going to launch a new advertising campaign, and we're given a series of options, and you need to find the optimal solution for a specific goal. And let's just take a look at that. So the problem says that this company has, so what are they doing? They're going to develop a new instant salad machine, and they have $282,000 to spend on this campaign. Notice how I have bolded $282,000 up here. I'm going to try to do that as we go through all the problems. I'm going to bold those things that, to me, it tells me that's something that I need for my problem. So $282,000 to spend, that sounds like something very important. I need to know that. The product is to be initially test marketed in the Dallas area. Fine. The money is to be spent on a TV advertising blitz during one weekend, Friday, Saturday, and Sunday. I didn't bold that, but that's actually important because that defines the weekend. I would have thought it was a Saturday and a Sunday, but here's a Friday, Saturday, and Sunday. So we have 3 days to worry about. The 3 options available are a daytime advertising, daytime advertising, that's one, during the day, a evening news advertising during the evening, and a Sunday game time advertising. Notice, this was interesting. Notice how, let me bold those 3, because that's important. Notice how, even though there are 3 days, here they're telling me that one of them is a Sunday game time advertising. So that's not something I can do on a Friday and a Saturday. I can only do it on a Sunday. Okay. So they, of course, they prefer if there's a mixture of 1-minute TV spots, if possible. So they definitely want to use all the possible tools they have. Okay, so we have a table. They're giving us a table where, as you can see, we have the 3 ads: the daytime, the evening, and the Sunday game, and each of them has a different reach. And by reach, that is, how many people are going to see it, or hear it, watch it, whatever that is. But that's their reach, and each of them has a different cost. As you can see, the Sunday game, of course, has the highest cost and the highest reach, but also it's a thing that you can only do once a week. So that's kind of a constraint. You have to think about those things. Okay, SMM wants us to take out at least 1 ad of each type: daytime, evening, game time. So that means that you need to have at least 1 of each. So daytime plus evening plus game time has to be at least 3. See, because 1 of each will be 3. So that has to be greater or equal to 3, at least 3. Further, there are only 2 game time ad spots available. There are 10 daytime spots available and 6 evening news spots available daily. Okay, so now they're giving us some constraints about how many of these ads we can take. We can't take any number we want. There's the number of advertising is capped by something, some reason, whatever that is. Probably because there are other, obviously there are other ads that are being played at the same time, so there's just a limited amount of spots available. SMM wants us to have at least 5 ads per day. Okay, so in any given day, the addition of the 3 has to be at least 5. but you cannot spend more than 50,000 on Friday and no more than 75,000 on Saturday. Okay, so the multiplication of the number of ads times the cost in any given day cannot be more than 50,000. Okay. So the question is, what combination of these 3 ads per day, weekend, would yield the highest reach? So that's your goal. The goal is to maximize the reach. You want to maximize, given the constraints, you want to maximize the number of people that see this ad, hear it, see it, whatever that is. It's a TV spot, right? So people are going to watch it. Yep. So the next thing you're going to do is you need to define all the different variables, all the different things that are going to be all the controllables, right? The things that you can control, which is going to be how many ads on Friday, Saturday, and Sunday, and what type, right? Is it going to be a daytime? Is it going to be an evening? So I come up with this, and we're going to have, look, you should look at them in blocks, right? Ouch. This many. These are your daytime. Right here, right? These are your daytime on Friday, Saturday, and Sunday. So I'm going to call them DFR for daytime Friday, daytime Saturday, daytime Sunday. And here we have the evening Friday, evening Saturday, evening Sunday. And then here I have the Sunday game time ad by itself. So these are my unknowns. So now I'm ready to start writing the objective. My objective is going to be to maximize these ads and their reach, given that each of them has the potential to reach this many people. So 3,000 DFR, which is 3,000 times the daytime on a Friday, plus 3,000, which is a daytime on a Saturday, plus 3,000 daytime on a Sunday, plus 4,000, which is the reach of an evening ad on a Friday, plus 4,000 on a Saturday, plus 4,000 on a Sunday, plus finally the game time on a Sunday. So that's your goal. Now the constraints are a little more difficult. Those, as you can see, those are going to take a little bit longer.